Okay, we're on to day 2 with hyperbolas. As with like we did with parabolas and ellipses, day 1 was all about graphing, day 2 is going to be about writing equations. The only thing that's new is hyperbolas, like an ellipse, have eccentricity. And it's the same as it was with ellipses, so it's c over a. But in this case, since your c value is always larger than a, it's always going to end up being greater than 1. And the larger the eccentricity, the flatter, so like this first picture your hyperbola is going to be, the smaller, the more pointed or more narrow your hyperbola will look. So as we're working through today, keep in mind these different formulas are general forms as we're writing these hyperbolas. So we'll start with a couple together, then I'll let you try a couple on your own. So for number 1, again with these, it can be helpful to draw a rough sketch. So we have vertices at 1, 6 and negative 5, 6. So 1, 2, 3, 4, 5, 6, and negative 5, 6. So these are our vertices. They're horizontal from each other, or to the left and right. So we know our hyperbola is going to look like that. So this is going to be horizontal right off the bat, which horizontal means your x portion has to come first. So keeping in mind that general form for our hyperbola. Okay. We have foci at 3, 6. So 1, 2, 3, 6. And negative 7, 6. Right there. Okay. So for us to figure this out, we need to know hk, we need to know a squared and b squared. So hk, remember, that's our center. So for us to figure out the center, we need to figure out the point in between these two vertices. So we have vertices at 1, 6 and negative 5, 6. So right in between would be over 1, 2, 3 to negative 2. 1, 2, 3. Yeah. So our center is going to be at negative 2, 6. So we'll have x plus 2 squared and y minus 6 squared. To figure out a squared and b squared, remember a is that distance from the center to your vertices, which in this case would be a distance of 3. So a is 3, which means a squared is 9. Lastly, the other piece we have are foci. We don't have our covertices, which would tell us our b value, but we do have our foci. And the distance from your center to a focal point, that's going to be c. And this distance is 5. So we're going from negative 2 to 3. So that's a distance of 5. So if c is 5, then that means c squared is 25. So we need to use the fact that a squared plus b squared is c squared. So we plug in 25 for c squared, plug in 9 for b squared, subtract 9 from both sides, we get b squared equals 16. And we don't need to find b because all it's asking for is b squared. And there we go. That would be our hyperbola. Okay. On to number 2. So again, as always, being able to identify these points or draw a little picture can usually be pretty helpful. So we'll start with our vertices. So we have vertices at 1, 14 there, and at 1, negative 2. So our center is going to be right in between. So I know this distance from negative 2 to 14, we go up 2 and then up 14, so that whole distance is 16. So half that distance would be 8 to get us to our center. So our center would be at 1, 6, because negative 2 plus 8 is 6. And this is a vertical hyperbola, so we know our y term has got to come first. Okay. Our center is at 1, 6. So it'll be x minus 1 and y minus 6. A squared is your distance from the center to, or a is the distance from the center to one of your vertices, which is 8. So that means a squared would be the same as 8 squared, which is 64. To figure out our b value, so we're given endpoints of the conjugate axis at 8, 6 and negative 6, 6. The conjugate axis, that just refers to the axis of your b value. So your covertices is what we often call those. So the distance from your center to one of these points, that actually tells us our b value. So the distance from 1 over to 8 would be 7, so that means b is 7, which means b squared would be 7 squared, or 49. And that would be our equation. Not too bad. All right. Okay, so you have 2 more. I'd like for you to try both of those on your own. They're asking for some different things, but in both cases you're given vertices or one of the vertices, or a vertex. Think about your equation for asymptotes, what those represent, and see if that can help you determine or figure out how to go about this problem. Okay, pause the video, give them a try. Okay, we're back. So let's start with a picture. So we have vertices at 9, 14 and 9, negative 4. So it's another vertical hyperbola, so that means I know y squared has got to come first. So our center is going to be directly in between here. So our distance is 4 plus 14, so the whole distance is 18. So half the distance would be 9. So 4 plus 9 would get me to 5 here. So this point would be at 9, 5 for our center. So y minus 5 and x minus 9. Our a value here is that distance, so a would be 9, meaning a squared would be 81. We got to figure out b squared. So let's think about what we have. So we have our 2 asymptotes. So these are going to be these asymptotes. And let's think about how these asymptotes work, particularly what their equations are. So with these asymptotes, notice they're y minus k. So I'll write that here. Y minus k equals plus or minus a over b times x minus h. So as we look at these, notice the slope here being a over b. Well, we know that a is 9. So that would mean b would just be 8. So all we need is really the slope to be able to figure out that b value. And there we go. Okay. On to the last one. So this one we have a center at 4, negative 3. We have a vertex at 4, negative 7. Okay. So the vertex is below, so we know it's going to be a vertical hyperbola again. So that means our y term is going to come first. We have the center, so we have hk. So we'll have y plus 3 squared and x minus 4 squared. We know our distance here from the center to the vertex is a distance of 4. So a is 4, meaning a squared is 16. And we have the eccentricity, which is c over a. So we know that c is 5, which means c squared is 25. So keep in mind, a squared plus b squared is c squared. Well, a squared is 16, b squared is 25, or c squared is 25, so that means b squared has to be 9. That's all there is to it.